My name is Mark Reinhold. I work at Oracle on Java, have been for many years. And this talk is about the modular Java platform and Project Jigsaw. So this is an update relative to last year. Some of the material will be kind of the same because I want to make sure I can introduce concepts to people who haven't seen this before. So if you have seen it before, bear with me, but there's definitely new stuff in this talk. So what I'm going to talk about first, high level, the goals of this project, the status, where we are, where we aren't going to be. I'll describe modularity concepts, in particular the module declaration language that we've been designing and prototyping and working with. I'll talk about packaging concepts, relate the modularity concepts to actual packaging artifacts, both a Java-specific module file format as well as native OS formats. And finally, I'll talk about modularizing the JDK, which is one of the ultimate goals of all this, and given the size and scope and age of this monolithic code base is quite a challenge. So, goals and status. So what are the problems that we're trying to solve? One of the big ones is application construction, packaging, and installation, and publication and installation. The famous jar hell problem. It's kind of sad that large Java applications are so brittle in that they're typically constructed with a class path of tens or dozens or even hundreds of jar files. I've seen applications inside Oracle with a class path over 1,000 jar files, which is kind of frightening. Looking back at the history of Java, if there's one thing I could have changed, if I had had the power to change in 1996 or 7, and of course I was a very junior guy at the time, it would have been, let's introduce a module system because this thing is going to grow like weeds and it's quickly going to be out of control. And well, that happened. So now we're having to go back and do it all the hard way. So solving jar hell is a big goal. Another big goal is to be able to scale the platform, scale the SE platform down to small devices, and actually converge Java SE with a higher end ME, that is the CDC platform. Moore's Law is now giving us enough transistors on really small devices that we can run a stripped down hotspot VM, and we can run actually all of SE if there's enough static memory to hold it. There isn't always. So being able to have a well-defined subset of the platform so that you can configure just the parts of the platform that you need, deliver them with your application, will be a compelling way to get the SE platform to scale down. And then finally, while we're doing all this, we have a great opportunity to address some long-term performance problems. One is download time. It is still interesting, the whole problem of downloading JREs onto consumer desktop, laptops, and other devices. When the minimal Windows JRE, even though it's highly compressed, is I think it's still around 15 megabytes. Especially if you don't have the luxury of a fast line, that can take quite a while. Let's figure out how to do just the part of that you need. And also startup time. The more stuff you have on the class path, the more time you have to spend scanning it just to get the JRE started up, and that's painful. So the solution to this, there is a magic bullet. Well, no, there isn't, but it kind of looks like one at a high level, is to modularize the platform. Introduce a module system, use it to modularize the platform, and also use it to modularize applications. So it enables us to escape from jar hell. We eliminate the class path. We record dependencies amongst modules directly in source code. It's just more facts about your code. It shouldn't really be anywhere else. We can package modules very easily for automatic download and install, and we'll actually demo that in a little while. We can also easily generate sensible operating system specific packages, so we can provide a very natural installation experience on platforms that already have good native packaging systems. We can scale the platform. Well-specified subsets of SE can fit into small devices, and we can improve performance. We can download things incrementally on demand, just install the stuff you need. We can also optimize module content during installation. One of the long-term things that I expect Jigsaw to enable, the module system to enable, and I'm quite excited about this, is we finally have a sensible way of doing ahead of time compilation. When you install a module, we could do basic compilation of methods into native code, and it won't be highly optimized, but it could well be enough to make startup time significantly faster. It's possible to do this with a hairy class path today, but to actually make it work is very, very difficult. There are people who have done this, and if you ask them, they will explain to you how difficult it is. Okay, so what is Project Jigsaw? Project Jigsaw at a high level has two phases. In the first phase, we're exploring a particular part of the modularity solution space. One part of that space has already been explored very thoroughly by OSGI and similar systems. We're taking the opportunity to explore a different part of it, taking on some different design principles. We're trying to build something that is simple yet scalable. We're trying to build something that is approachable by all developers, but powerful enough to modularize the JDK. And also importantly, we are exploring ways that we can leverage the ability to change the virtual machine and the language and the libraries to come up with a really good module system, which is something that OSGI was never able to do because it always had to build on top. Now, it's still impressive what OSGI was able to do given that limitation. Anyway, so phase one, we're exploring this other part of the design space because introducing a module system to the Java platform is something that we can only do once. This isn't going to be like Java util date. We did Java util date in Java 1.0 and we realized that sucked, and then we did Java util calendar in Java 1.1 and that hasn't worked out so well. And now we're trying to really nail it this time with JSR 3.10 and the date time API, and I really hope it does. But we can't play that kind of game with something as fundamental as a module system. We have to get it right. So it's important to explore as much of the design space as we can before we get into phase two. With phase two, Project Jigsaw will shift gears and become the reference implementation for a specification to be created by the expert group of a forthcoming module system JSR. Because since all important specifications are governed by the JCP, this is how we have to do it. And this is the best way to ensure that everybody in the wide Java ecosystem has an opportunity to give their feedback and comments into that process. So that's the two phases of Project Jigsaw. And at the end, we'll commit the transaction and we'll have a module system, hopefully one that everyone can use. Okay, we've made a lot of progress since last year. I'm not going to go through every little detail here, but we've struggled with some really tough problems trying to understand the best way, trying to come up with a clean conceptual model for a module system, yet still have the expressive power we need to modularize this enormous legacy code base that is the JDK. So among other things, we've extended the module declaration language with three additional concepts: exports, views, and services. And I'll show two of those later on. We've done a lot of internal plumbing work that isn't very glamorous, but in some cases was pretty tough. For example, we have the hotspot VM now can bootstrap itself, reading the primordial classes through a native interface that is part of the module system. This is work that Mandy did and Karen Kinnear did, and this required deep surgery under the covers to make it happen. Our earlier prototypes just had a hack, basically, where the hotspot VM knew where inside a module library to find something and assumed it was in a certain format, but whenever we changed that in the module system build, hotspot would break, and that was no good. So now we're doing that the right way. We've converted security providers into true services. We implemented the removal of installed modules, sort of duh. We have the ability to compress installed modules. This is important for some embedded devices where there's enough processing power to do decompression of class files on the fly. So you can actually save time because memory bandwidth is so limited. You can save time by compressing all the class files in the module library and then decompressing them as you load them into the VM. A variety of other things here. We now have a very tiny subset of Berkeley DB integrated in the Jigsaw code. We're not quite using it yet, but we're going to use that for stored module configurations. That will make modules start up very, very fast. And finally, we also have Mac and Solaris 64-bit builds. And finally, we have early access builds. So we've been shipping early access builds since, I think, around June, maybe a little earlier. They're not weekly. They're kind of irregular depending on when we make big changes. But you can get early access builds at that URL. When we update them, we send an email out to the Jigsaw dev list, so you can subscribe to that if you want to get updates. Okay, status. So as many people probably know by now, we took a hard decision a little earlier, late this past summer, to defer Jigsaw, the entire modularity effort, from Java 8 to Java 9. This was painful. This wasn't fun, but I think it was the right thing to do. It's, if you can see a year out that something is unlikely to make it, it's better to defer it then than to defer it 3 months before you're about to ship. Why did we do this? Some significant technical challenges remain. There's this entire sub-problem of dynamic modularization, which I'll go into a little bit later, where in module mode with Jigsaw, the mode of operation is quite different from the regular class path mode in some small but important ways. And chasing down all the different places that are affected by this takes some time. Another thing we haven't done yet is support for containers. By that I mean things like EE application servers or applet runners or IDEs that want to have dynamic plugins and things like that. To support containers well, we need a reflective API on the module system itself, so that an app server, for example, can tell the module system, okay, now I want to load this web app over here that's in a set of modules that were delivered to me in a modularized WAR or whatever. It needs to be able to change the module graph at runtime, create a subgraph of the regular module graph, hook everything up, and then when that web app, if that web app is undeployed, has to be able to dissolve that module graph and unload everything. It's something that we know how to do, but it's going to take some care to get it right. So technical challenges were one reason for the deferral. The other reason, and I think the more significant reason, is we were just running out of time for the broad review and testing and feedback that a change of this nature requires. This is, as I said, a profound change to the platform. It's not something that we should rush in. It's going to affect the entire ecosystem in the long run. So given that essentially the specification freeze date is, at this point about 7 months away, it would be the wrong thing to try to rush it in, even though it is disappointing to have to defer it. Anyway, so I made this argument in my blog a couple of months ago. There was a lot of discussion in the community. We discussed this in the Java SE8 JSR 337 expert group, and in the end decided to defer it. And I know some folks are disappointed with that. I myself am disappointed with that, but as I said, I do think it's the best decision. Okay, that's it for goals and status. Let's move on to some concepts. So this is a little bit of a deep dive into the module declaration language that we've prototyped in Jigsaw. The fundamental concepts are grouping, dependence, versioning, permits, optional modules, module aliases, exports, and views. So this list is a little longer than it was a year ago. Okay, so let's start at the beginning, grouping. Here we have a class, com.foo, main. It imports some stuff. It's fairly simple. Presumably there's a main method in there. We compile that, we get a main class. We have some other stuff. There's a ComFoo other class nearby. We compile that. We get ComFoo other. There's maybe a subpackage called com.foo.ui. We compile that. We get one more thing. We've now got 3 related classes. We want to describe these as being in one module. And the way we do that is we have a new part of the Java programming language called a module declaration. Module declarations go, by convention, go into files called module-info.java. This is expanding on an existing convention of package-info.java, which is a source file where you can put package annotations. So this is where you put module declarations. And this is really, really simple. You just say module com.foo, and well, there's an opening brace and a closing brace because I'm not saying anything interesting about it yet, but don't worry, I will. So you say this, and then at least conceptually, you now have a module. And in terms of the file system layout, this all works in a pretty natural way. Module-info.java is just at the root of that part of the source tree, as you'll see later. A module can have an entry point. So com.foo.main presumably has the main method of this application. So in the module declaration, if I just say class com.foo.main, that declares the entry point. And then once I've installed this module and all the modules upon which it depends, I can tell the Java launcher, rather than give it the name of a class and a big long hairy class path, I can just say, go run the module com.foo. And it'll go find the entry point and invoke it and link everything up. Okay, external libraries. Suppose this app depends on some stuff in org.bar.lib something or other and edu.baz.util something or other. The traditional way to solve this, of course, is to descend into jar hell and have a bunch of jar files on a class path. That's the world we're trying to escape from. So in the modular world, we declare dependencies. In my declaration for the com.foo module, I say requires org.bar.lib, which is not only the principal package name, but by convention, the name of that module, and requires edu.baz.util. And in graphical terms, that introduces arcs. We now have a non-trivial module graph here for the com.foo module, an org.bar.lib module, an edu.baz.util module, and the dependencies between them. Versioning. Yes, versioning is its own rich topic. I could give an entire talk about it. I'm not going to. You can put, let's just for now say you can put version numbers on modules. When you declare a module, you give a specific version number. When you require another module, you can give a specific version number, or you can give things like ranges. You can say, give me version 5.2_11 or later, or earlier, or something like that. So there are a variety of things you can do. In Jigsaw so far, we've taken the view that the module system shouldn't impose specific detailed semantics on version numbers. That's not a position everyone agrees with, but it's the most sort of neutral position, and it's actually the position taken by the successful operating system packaging systems out there. Okay, permits. So modularity, a big part of modularity is encapsulation. It's hiding things so that you can change them at will later, and because you know that no one else could have depended upon them. So this graph shows a somewhat richer structure. We have a ComFoo app module at the top. It depends on ComFoo lib, which in turn depends on ComFoo secret and org.bar.lib and edu.baz.util. Now, all of this stuff defined in these bottom modules is implicitly kind of re-exported up into ComFoo app, including ComFoo secret. But suppose we don't want that to be re-exported because, well, gosh, it's secret, isn't it? And we don't want any other module that might come in later that's not even related to this application come in and depend upon ComFoo secret, because we want to be able to change it whenever we want. And maybe it actually has other secrets in it. So there's another construct in the module declaration syntax called permits. So in the declaration of the confu secret module, I can say permits confu lib. That means confu lib can depend upon it, but no one else can directly depend upon it, and its types won't be re-exported, cannot be re-exported out of confu lib into any of the modules that use confu lib. Okay, there's also a notion of optional modules. Sometimes you want to be able to structure an application so that if some other module is already installed, it can take advantage of it. But if that module isn't installed, the application will still itself install and run. This is a typical example of where this is useful is for locale-specific resources. You might want to put all of your locale data for Asia in one module, all your locale data for Europe in another module. And so when you deploy your app, you install just the locale modules that you want. Your application has optional dependencies upon them. So if they're there, your app will find them. And if they're not, your app will still work. It just won't have the data for those. Okay. Okay, splitting. Whenever you have a way of constructing, graphs like this, a language of dependencies, it's critical that you have the ability to refactor the shape of the graph over time. And so the basic operations there are splitting and aggregation. If we want to split a module, in this case we've got confu lib. Suppose it's growing over time. We decide we want to split it into several modules. We can do that. But suppose we don't want to change confu app, or we don't have the power to change confu app. Maybe it's a third-party module, or it's from another team that has a different release schedule. We can do that by introducing what we call an aggregator module. So there's still a confu lib now. It doesn't actually have any content of its own. All it does is require these other three guys, so that the dependence from confu app upon confu lib still works as expected. Now, the inverse of splitting is aggregation. If we're in this situation where we've got confu app depending explicitly on these three, and then we decide, oh, well, we actually want those three to be in just one module and unify it. But again, we don't have the power to modify confu app. We can aggregate them into confu lib. Now we have these dangling references because confu app, it's still referring to confu lib DB and confu lib UI and confu lib util. The way we get around that is with aliases or the provides clause. So in confu lib, we put in some declarations which say, not only is this thing named confu lib, but it also, if someone asks for confu lib DB, then tell them that this module will work. And that causes those references to be resolved directly to confu lib when the modules are installed. Okay, exports. This is new. So we've got confu lib, this other module confu lib DB. Now imagine there are some classes in confu lib DB that we want to export to confu lib and whoever else uses this. And there are some internal classes that we don't. Now, what's going on here basically is within confu lib DB, all of these classes are public. But we don't want all of the public classes to be exported outward. These two classes need to be public because they're going to be accessed by classes in the exported packages. But we don't actually want these to be sort of globally public, as it were. So there's a kind of subtle thing going on here. We're actually changing, with the introduction of the module system, we're changing the meaning of public. So public used to mean visible to everybody. What it means now is visible to everybody in this module and visible outside this module if the package is exported. So in order to control this, we use an exports clause because we only want confu lib to see this stuff. We say exports the package confu lib DB, and that causes these two classes and whatever else is in these packages to be hidden. They cannot, at a deep fundamental level in the virtual machine, they cannot be accessed from outside this module. Now, a related thing to exports is views. One thing we discovered while modularizing the JDK, we originally started out with lots and lots of modules. As we trimmed that down, we discovered that we were often needing pairs of modules because there needed to be a module of some code in the JDK that exported a bunch of stuff outside, and then a very tightly related module that had classes that were only used within the JDK, and we didn't want those exported outside. So we always had these module pairs, and it made things hard to reason about. It almost doubled the size of the module graph in some ways, and that wasn't very satisfactory. So we introduced the concept of views. The idea of a view is that think of a module as exporting a set of bindings. By default, it exports the set of bindings in the packages in its exports clause. Of course, you can have more than one of these, I should have said. You can have as many export clauses as you want. A view defines another set of exported bindings with a different name. So if I have some confu lib other module, and I actually want to give it access to these, to all of this stuff, I can define a view in this module declaration, say call it confu lib db internal. I can say that it permits only this module confu lib other to link to it. And by the way, in addition to the confu lib db package, it also exports confu lib db internal. So this module sees these two internal classes, whereas that module still doesn't. So views have proven to be very powerful and really let us clean up the overall JDK module graph. Okay, so that's the quick deep dive into modularity concepts. I'd like to talk about packaging for a bit. So concepts here are module files, libraries, repositories, and native packages. So let's look at some command line stuff here, just to make it really concrete. And this is stuff you can type in and it works. We've modified the Java compiler, Java C. It understands a new convention which we've called module path, which is a way of structuring source code and compiled code directories in a way that reflects the module structure. So you can run Java C on some code. This is telling it module path mods. That's instead of -d classes, you say module path mods, and your compiled modules will wind up in here. If we look recursively into mods, so in mods there's one directory for each module that you compiled, and then if we look into one of those directories, we'll see that we'll see the compiled module info at the root of that one. And then underneath it, the usual package structured hierarchy of directories and class files. Once we've done the compile, we can package those class files up into a variety of formats. One format is called JMod, which is a Java-specific format. It uses pack 200 on the class files, so it's extremely compressed. It can also handle native code, resources, and other things. You do that, then in this case, we get 3 JMod files out the back. As you can see, just by convention, the file names reflect the version numbers. Once we have the JMod files, we can create a module library. A module library is, you can think of it as a little database into which you install modules. It has some internal information to make things fast. This is where Berkeley DB comes in. Create a module library. We can install those other modules that we needed from wherever we got them, org bar lib and edubaz util. Then we can install the 3 modules we just compiled, including confu app. Now when we do that, the module system will resolve all the dependencies, make sure everything gets linked up, and it will pre-compute information, which ultimately we'll store in a really fast B tree, so that looking up class files at runtime is very efficient. We're no longer dealing with zip directories at the ends of files and seeking around and stuff like that. We're pulling information out of a B tree and being very efficient. once we've installed modules, we can use the ls subcommand to ask, well, what's in this module library? And of course, ls-v will tell you a lot more. And finally, as I mentioned earlier, we can use the Java launcher. We tell it, look in this module library, and instead of naming a class and giving a class path, we say, go find the module named confu app, -m for module, and run it. And it does. Okay, one library can delegate to another. And in fact, the Jigsaw prototype JRE has its own built-in module library, surprise, surprise, which has whatever modules of the JDK that you've installed. And our little example module library, mlib, delegates to the system module library. By default, every module library you create delegates to the system module library. You could delegate in a chain if you wanted to. Anyway, so delegation does kind of the obvious thing. If one library delegates to another, then when you install things into the child library, dependencies will be resolved up through the delegation chain. Okay, we also have a concept of repositories, as in a web-hosted repository of modules that, from which you can download modules that you need. So I could have a full repository of all the JDK modules on some host somewhere, have a module library refer to it. And now if I can go and use another subcommand of this JMod utility and say, add this repo, jig.sfba, whatever it's called, go install the JDK tools module. And you say, okay, I need Java-C now, but Java-C isn't among these modules. If I ask it to install jdk.tools, it goes and does it, and then I can run the compiler. Okay, native packages. So we have enough information in these module declaration files to create sensible native packages, at least for operating systems that have sensible native packaging systems. We have this language that allows you to express a versioned dependence of one module for another, and that's exactly what we need to, for example, create Debian or RPM files. And there's another way to invoke the JPackage tool that will get you Debian packages. We haven't implemented the RPM one yet, but it's very straightforward since they're isomorphic. So from confu app in module form, we can create confu app.deb. And I know that syntax isn't actually perfect according to the Debian policy guidelines, but we'll fix it. When we do this, that dependence in green from one Java module to another is reflected in a dependence that winds up in the Debian package control file. So that when you go to install these packages on your Debian machine, all the other Java modules that you need will also be installed. Okay. Modularizing the JDK. This is the fun part. So the JDK up till now has been developed as a huge monolithic software system, and it has all of the usual problems of huge monolithic software systems. When we did the first cut at modularizing it back in 2009 or so, this is what we got. Mandy remembers this. It was really painful. So there are 50 nodes in this module graph and 171 edges. The module up here in bold red, which you probably can't see from the back of the room, is called base. That's the most fundamental module. That's the module that you have to have. It has Java lang object in it, right? So one of the goals here is you should be able to install a JRE, and the only module in it is base. You can't have a JRE without base. That's useless. You have to have base because you need Java lang object and Java lang string and a few other things just to get the VM off the ground. So the first question I asked about this graph, once we had it, was, okay, if I install base, does it drag in any other stuff? And the answer is yes. It drags in quite a lot of other stuff. For those of you who can't see from the back of the room, let's see, it drags in logging. It drags in Kerberos. It drags in pack 200. We don't need pack 200 to start the VM. It drags in, that's my favorite, it drags in Corba. Definitely don't need Corba to start the VM. So if we left it here, we obviously wouldn't attain our goal of being able to scale this down to small devices, because we're talking about installing 2/3 of the existing modules just to get base to run. So Mandy and Alan and others did a lot of surgery. We spent a lot of time digging into the code, finding internal dependencies from one internal API to another, or an implementation of a public API to some internal API, and found that, well, a lot of them were gratuitous and could be removed, or some code refactoring would allow such dependencies to be removed, or in some cases, modest API changes, some of which we actually made in Java 7, would allow them to be removed. And eventually came up with a much simplified graph. So this is where we are today. There are 32 nodes and 105 edges. This is actually a little bit, this isn't quite reality, but it's a comprehensible version of reality. To make it even more readable, there's this form of it. This is the transitive reduction of the previous graph. So this is the graph that we would expect people to here print this out. So what I would do anyway is print this out, put it on my bulletin board, so I know what the module graph looks like. So that's the after picture. How does this work in practice? Well, you might have seen the demo I did in the technical keynote on Sunday. We've had this scheduler app running. You've probably seen the kiosks in the hallway, this amazing scheduler app that Jasper Potts and Rich Bear wrote in JavaFX, and Jasper built these physical kiosks that are spread around the hotels. That's a JavaFX app. My colleague Alan Bateman took that app, modularized it. He also modularized the JavaFX runtime, so we can install the scheduler app in a modular form. All that the scheduler app needs from the JDK is 3 modules: TLS, which is the SSL, logging, and of course base, because you always have to have base. The scheduler app needs some other stuff. It needs the JavaFX embedded runtime, or the whole one. That depends on the device you're running on. It needs another module, a module that has some modeling classes in it. The scheduler itself uses the logging API. It also uses the Apache HTTP client and HTTP core libraries, which we converted into modular form. We actually have a tool that will take a jar file and convert it into a modular jar file or a JMod file and deduce the versioning information that's needed. And then HTTP client and HTTP core drag in their own dependencies, and apparently no Java program is complete without at least one copy of Commons logging. There it is. And it works. So let's show that it actually works. Mandy has it warmed up and ready here. Let's switch to run 4. Okay, so which Java? Okay, JMod LS, or Java dash version. Jigsaw nightly. We don't actually need that one, but there it is. How big is it? That's an implementation detail. It will disappear in due course. 23 megabytes. So this is a bigger number than with the embedded build, which is what I demoed on Sunday, because this is not the embedded build. This is just the regular JDK, server desktop build. JRepo, that's not a command. I think you need to say jmod repo. Oh, does that work? Okay. I missed that change set apparently. Right, so these are the modules that are available. They're not installed in this JRE, but they're available in the repository that it's connected to. Okay. Sorry, it's not connected to it yet, but it will be in a moment. Yeah, it's fine. you just established the link between the library and the repository. So that shows you everything you can install. Now, can you do a jmod install-n? This will tell you, oh, here we're asking it, tell me what you would need to install and how many bytes it would take. So it comes back and says, well, I need all these modules that would take that many bytes to download and that many bytes to store. Okay, now let's do it for real without the -n. Oh, we do that again. Okay. Now it's doing some work and it crashes. I just haven't had good luck this week. MSVCR100.dll already exists. Thank you. Let's do it the other way. Okay, so she's creating another module library, adding the repo link to it. There's everything we could install. Now we'll actually do the install. Ta-da! And now we can run it. Ta-da! And it comes up much faster than Raspberry Pi. All right. And it works. Thank you, Mandy. Okay. So that's the modular platform in actual use. It actually does work. And you can download it and play with it if you want. So I'd like to take a little digression here and talk about profiles. Jigsaw won't be in Java 8. But there's still a lot of demand for some way to scale Java SE, at least in a crude way, in cruder ways, in the Java 8 timeframe. So we're going to propose the introduction of a set of profiles to Java SE. This is, in the context of the JCP, this is using the profile concept that already exists and has been used in Java ME and also Java EE. We're now going to use that in SE. To define some smaller subsets, not as granular as modules, not as rich as the whole module graph, but something that will, okay, I'm out of order, sorry. Something that will allow small devices to be used in the near term rather than the medium term. So here's the graph we started with. This shaded part is the JRE. With an embedded Java build, this is 52 megabytes. What we're proposing is to define profiles that correspond as much as we can make them to the Jigsaw modules. And of course, we expect those to shift a bit, but we'll do our best to align them all so that there'll be a 10 megabyte base profile that contains the base module, TLS, authentication and logging. And then above that, this is sort of like the layers of an onion. There'll be a 17 megabyte or so module that contains a few other things, JDBC, RMI, and JAXP. JAXP, of course, is the biggest part of that addition. And then a third one that'll probably be around 24 megabytes that contains more JDBC stuff and Kerberos and JNDI and management and the compiler API. And other things. So this will give enough flexibility for a while that we can make some good headway to scaling Java SE down to embedded systems, even though we won't have the whole module system to work with. Okay, let me back up a bit and talk about compatibility. Okay, compatibility in the modular world. So our expectation, our goal, is that once we have a module system and a modularized platform, if you have an application that's composed of jar files in the usual way and runs on Java 7 or Java 8 or Java 6 even, today it will run on Java with a module system as long as it doesn't do two things. One is it doesn't depend upon the internal structure of the JDK or the JRE. If it goes and digs in and tries to do something directly with rt.jar, for example, that will fail because it won't exist. It also has to be the case that it only uses supported APIs and other interfaces. Digging into sun.reflect is a bad idea because that's not going to be exposed. So modularized applications will see some changes. For example, if an optional module isn't present. There are two modes of operation, at least in our prototype today. There's legacy mode, which is the usual class path, everything, as long as every module is installed, an existing application should just work as long as it doesn't depend on internals. And then there's module mode for the case where you have an application composed of a set of modules. In module mode, some things will be different. Optional modules might not be present. There will be some other differences. Tools or applications that depend on files in the Java home directory will require some change. rt.jar won't exist, tools.jar won't exist, the boot class path flag won't exist. So what I've talked about so far is primarily the process of static modularization. That is taking this giant body of code, dividing it up into modules, changing things so that we have a sensible, comprehensible module graph at the end. There's also a dynamic aspect of this, and this has turned out to be one of the more difficult technical challenges. I don't think we realized at the beginning quite how hard this would be. Because in module mode, certain things have to change. Module mode is different from class path mode. One of the fundamental differences is in class path mode, if you get a class object and you ask it what its class loader is, if that class came out of rt.jar, that is, it's part of the JRE, you get back this special value null, which is shorthand for the bootstrap class loader, a concept that's actually defined in the specification. Well, in module mode, there isn't really an analogous concept. In module mode, we needed a way to associate every class with a distinct class loader. So now if you go ask Java lang object, if you invoke its getClass method, you get back an actual live module loader. And if you have the right privileges, you can go do reflection on that and find out things about where it came from and so forth. But there are assumptions throughout the platform, sometimes in surprising ways, where people have inserted tests and assumed, for example, that it's okay to do a privileged operation if the calling class's class loader is null. Now, that may have been true before. It's not true now. So we're having to do a fairly detailed audit of the entire code base to find all of these assumptions. There's also the issue that some previously visible classes are just no longer visible. Some stuff in sun.misc, for example, it's finally hidden behind a wall, which is where it should have been placed in 1995. Okay, there are lots and lots of complexities here in some of our very favorite areas of the platform. Serialization, RMI, and Corba, which all do some amount of reflective magic, and all require some amount of privilege when you're running in sandbox mode. So it's quite delicate work to work through all this stuff. Okay, I talked about profiles. And I've talked about modularizing the JDK. Hasn't been just me working on this, or it hasn't been just me and Mandy, but a bunch of other people working on this for several years now, and at least a couple years more. So I just wanted to give them credit for that. The obligatory legal notice. And finally, there's a BOF. If you have questions, we can probably do a few questions now. But we also have this room for the next session at 4:30, and Mandy and I will be hanging out in between for Q&A. Places where you can go for more information. Our project page, our main project page in OpenJDK is the first URL. We have our development list, Jigsaw Dev at OpenJDK, and jdk8.java.net/jigsaw is where you can get the early access builds. Of course, we will shortly be changing that to jdk9.java.net/jigsaw, but we'll try to leave a redirect. I'd also like to mention there's a related project in OpenJDK called Penrose, where some folks are exploring the important topic of OSGI and Jigsaw interoperation. You know, Jigsaw is not trying to replace OSGI. There's lots of cool stuff OSGI can do that Jigsaw is not trying to do. So to keep OSGI-based applications working well, this interoperation project is really important. So if you want to learn more about that, you can visit there. We've got about 8 minutes left in this session for questions, so if you have any, please ask. Thank you. Yeah.
What about cyclic dependencies? Is the project going to do any warnings or just the developer avoiding?
The question is, what about cyclic dependencies? They work just fine. They might not be best practice, but they work just fine. It's the resolver handles them. It's just a graph. Okay, can you speak up, please? It's kind of hard to hear.
You mentioned explicit export clauses. If I heard correctly before that you spoke about implicit re-exporting. I'm wondering how this would interact. Could I turn off this implicit re-exporting?
Right, so the question is, I showed explicit export clauses and then I mentioned implicit re-exports. One thing I didn't show, because I wasn't sure I would have time, is you can control re-exports. In fact, we flipped this around in the prototype a couple of times based on experience. If you want to re-export, you have to say that explicitly. So if module A requires module B and wants to re-export what it gets from module B, instead of saying requires B, it says requires public B, and that will re-export everything. Although if B has a permits clause, that won't be allowed. Okay. Yeah.
How do you handle java.util? Split into many modules?
How do you handle java.util? Do you split it into many modules? It's a bit late for that. So what we have now is we have the power to split that up using an even deeper, more subtle feature called requires local, which allows multiple modules to be loaded in the same runtime class loader. But working out the semantics of that has proved to be pretty tricky. So we might just drop it. When the whole Jigsaw effort originally started back in 2008, one of our goals was to converge not just with Java MECDC, but also CLDC, which would require splitting up many existing packages. You know, as time has gone on, the CLDC goal has become less important. Yes, it's true, Java.util really, from the beginning, should have been probably 3 or 4 different packages that would not make 3 or 4 different nice modules right now, but it's not. So they'll most likely all of Java.util, not necessarily its sub-packages, but all of Java.util itself will wind up in the base module and stay there. Somebody who hasn't asked?
How do you see this affecting the Java EE applications and containers?
So Java EE, how do I see this affecting Java EE? I expect it will affect Java EE. Java EE is one of the most important customers of all this, and we've spent lots of quality time speaking with technical leaders in that community. The long-term goal is for Java EE to be able to adopt whatever module system winds up in Java 9, so that there can be a clean basis for truly modular Java EE applications. And I would expect the related Java EE standards for WAR files and EAR files and all that to be expanded so that you can, for example, have in one file somehow packaged up a bunch of modules that constitute your EE application for deployment. Yeah.
How about Sun-Miss gun-safe, like every other high-performance library uses it?
How about Sun-Miss gun-safe? So this is one I finally refer to as the Doug Lee problem, because every time I talk to Doug Lee, he politely reminds me that I better not take away Sun-Miss gun-safe, because then people won't be able to test out new versions of his Java util concurrent library. That's a really tough one. I mean, there's a lot of, frankly, garbage in the Sun-Miss package and some of the other old crufty packages that that just needs to go away. Sun-Miss gun-safe, you're right, it's important. I don't know what the right answer is there. If there were some way to, if I could give Doug a cryptographic signing key, and then only allow code written by Doug to link to Sun-Miss gun-safe, that'd be one way to do it. But I don't think it's really practical. One idea that was suggested recently, and maybe this is actually the way to go, is maybe we make unsafe part of the standard. Maybe we have java.lang.unsafe. If we do that, we have to make damn sure that the security around it is airtight, obviously. But given the importance not only to libraries that Doug writes, but libraries that some other folks write, that may be the best way out of that particular puzzle. Oh, sorry.
Two models dependent on different versions of the same model.
Can two modules depend on different versions of the same other module? Will that be supported? The answer is no. In practical experience, that does not seem to be a common case. I know it's something that OSGI can handle, and sometimes in really rich systems, you need to be able to do that. But if you look at, in the class path world, if you have two different versions of the same jar file on your class path, that's a bug. It might be a really difficult to diagnose bug, but it's a bug.
Oh, that's not at all the case. This happens all the time, right? Container loads, certain things that depend on different versions of.
Yes. So yes, K is observing that our old friend com is logging. There will be 16 different versions of it in a running app server, and that's true. And that's why that's one of the problems we haven't yet tackled in container support in the Jigsaw prototype. So we understand that in some controlled cases you need to have multiple versions of the same thing, but the view we've taken is that we want to do that in a controlled way, rather than solving the general problem of, oh, here's this big, huge sea of modules with arbitrary version constraints and everything. We're going to do it in a more controlled manner so that we actually can understand what's going on and reason about, for example, the correctness and the performance of the system. Okay, there.
What's it going to look like when we're converting our work into modules and we're still relying on third-party libraries that are delivered as jars and not delivered as modules? How's that going to look? What are we going to be doing?
Good question. What will it look like when we're What will it look like when we're converting our own projects into modules, but we still depend on third-party libraries delivered as jars? Well, I'd like to think there'd be a magic Eclipse plugin and a magic NetBeans plugin that would just do it all for you. In a more realistic answer is, so we've thought some about that problem. One answer we have for that is we've extended the jar tool to be able to add module metadata to a jar file. So if you got a jar file and you know what its version was, for example, we actually had a prototype of this we demoed last year, where you could go to Maven Central, download an artifact, and convert it into a JMod file that deduced all its version and dependence information from the POM. Because the POM, well, you look at a POM and from 30 feet away, it looks a lot like a module declaration. So that's one answer to that. We also expect to have, I mean, we built, Mandy built this nice dependence analyzer tool, which is how we constructed the module graph and simplified it. We'd like to get that into developers' hands and ideally into IDE plugins so that when you're starting with your own code and trying to figure out what its inherent module structure is, you can run that class analyzer and it will offer you suggestions about how to clump things up into modules. Is there anybody who hasn't asked a question yet?
Okay,
Be honest.
I have a follow-up on it.
Okay.
So I guess I got the understanding that ClassPath will still be supported.
ClassPath will still, there are two modes. You can be in ClassPath mode or you can be in module mode. You cannot mix them. You cannot mix them. We've thought about that. It's so hard to make sense of. You cannot mix them.
Thanks.
Okay. Yeah.
You mentioned briefly that there's not going to be null for the boot class loader. Is the class loader precedence changing?
So I mentioned that the boot class loader will no longer be represented by null. Is the class loader precedence changing? Do you mean, is the delegation model changing? Yes, the delegation model is changing. It is going away.
You can essentially have a local class loader in a bundle.
Sorry? Every module has its own class loader. You know, a module class loader knows about other module class loaders in a way that's precisely described by the module declarations. And that's all. There's no more delegation chain and inherent lookup that way.
That's where quite a lot of the container-based support is stemming from, because you can't just go and do.
Exactly. That is where a lot of the container support is based on.
You mentioned HTTP repository for Java modules.
Mm-hmm.
What is the format?
I mentioned HTTP repositories for Java modules. What is the format? It's really simple. It's static files on a web server. There's a little tool, that's the JRepo tool Mandy showed. There's a little tool for maintaining a catalog file in the root of such a repository, but otherwise it's just JMON files. Simple static web server. You don't need to install a servlet or any server-side code. You know.
I wonder how this will relate in the future to Maven repositories.
Wonder how.
With Maven.
Right. How will this relate to Maven? That's a good question. Another existing system that we aim to interoperate with is Maven. You know, the details of that. You know, we prototyped some stuff. We showed it here last year, but we need to work more on that. And we hope that there are folks in the Maven community who are interested in helping. Well, we already know a couple of them. So. But over there.
When we will have the final version of this JDK Jigsaw, how do you expect the users of Java community to embrace it? Like, for example, this is going to involve a certain level of learning curve to all the developers who are currently working with Java. So I just want to know in which way the release will be made, and how will the existing production and new applications would be expected to change this release?
So how do I basically how do I expect this to be adopted? Slowly. I mean, let's be realistic about it. It's a huge change. I expect, you know.
I was just thinking if there will be two different paths for Java, where one will be the standard Java that is existing as of today, and there will be another version of Java that is coming out as modular Java. On a due course, this and the other one will get embraced.
No, it's not a fork in the road, right? Once we have a module system in Java 9, there will be a module system there. You know, you can use it or not. Just as in Java 5, we introduced generics. You could use them or not. Over time, most people learned that the benefits outweighed the disadvantages and converted to using them. But we understand it will take time. We understand that education is going to be an important part of this. So we're actively looking, for example, for a really good tech writer to write the canonical Jigsaw book in due course. We expect training will be a big part of it. So yeah, it is a big change, and it'll take time. But we have no plans to take away ClassPath mode, right? maybe in 20 years, but that has to stick around for a good long time.
Mark?
Yes, sir.
Is there still room for OSGI?
Well, yeah.
You see it's totally out of the picture.
Is there still room for OSGI? So, OSGI is not out of the picture. It's meant to run on top for those who need it. And this is what's going on in Project Penrose. Is they're working through the details of how do you make an OSGI resolver hook into the lower layers of Jigsaw, so that an OSGI bundle could say, requires JDK.base version whatever, and have that all work. So supporting OSGI is an unarguable requirement. Basically, it's just that OSGI itself, there are problems we need to solve to modularize the platform that OSGI can't solve. Okay, I think they're going to kick us out of the room so that everybody can be rescanned, but we can all come back. Thank you.